too difficult questions on printers. And then we looked at formatted I/O using the printf and the scanf. So you should be familiar with those statements. Okay. Then we started looking at operators and expressions, assignment operators, arithmetic operations, electric field. Oh, I do have electric field on the brain, don't I? Precedence and associativity. So what orders are done in which, what operations are done in which order, and how to change that if you need to. And then relational and logic operators. Remember the little math signs, the exclamation point, plus plus, minus minus. Remember those? What? And. Good. Okay.
Go and.
So we continue with that, and we looked at compound assignment operators, increment and decrement operations, cast operators, and then conditional operators. Right? If this is true, do this. If that's not true, then do that. Okay? So then we moved into more complicated statements and control flow. So the first thing we looked at was just basically you have a simple statement or you have a compound statement. It's either one thing or a couple of different operations. And then we looked at expressions and null statements. And why do I need a null statement? Anybody remembers? Okay, well I guess I'll have to put that on the
Damn it.
If you have like a if then and you don't want it to do anything, if it's not true, then you use a null statement. It's just a filler, right? So if the syntax of your code requires a statement, but you don't need it to do anything, that's why you have the null statement. So then we went on a little tangent, walked through the garden path a little, maybe took a different path and talked about flowcharts. Oh, and that should say flowcharts and pseudocode, because we talked about that as well. So you should know the flowcharts, and you should know the 5, 6 shapes. Is it five shapes?
Square.
So I might ask you to, I probably will ask you to write
Circle.
a flowchart. I'll say, I want you to do this, to write a code to do this, and I would ask you to flowchart it, pseudocode it, and then write the actual C code. Okay? And maybe link a database of, let's see, potential affiliate faculty to a scheduling database. I'm joking. Don't look at me like that. Land. What? She's like, oh shit. Is she serious?
I'm thinking notes.
Oh darn. Sorry.
Write this down.
Yeah. No, I was joking. That would be a little complicated. I mean, something like what we've done in class.
Blackmail.
You know, calculate the force between, an electron or something like that.
Will you give us the electrical formulas for that stuff?
Dude! Are you an electrical engineer?
Maybe.
It's Mike D. He's on the file.
We're electrical
Maybe.
engineering students.
Depends on who's asking.
Even
Did you ever specify the distance between the charges when we asked us to do that?
No, why wouldn't you input that?
Or make it up?
Yeah.
Just here's two charges, the distance between them plus the K constant. Voila.
Voila!
And
Voila! That easy. Yes.
seriously?
Well, force usually is in newtons,
She will not.
unless you got some
Yeah,
kind of
unless you're
dying thing
American.
going on. What?
Oh, the
We
it's
use
just the
newtons
Ohm's
for
law.
force, don't we?
well, here's the
What the hell's
problem
Ohm's
with
law?
manufacturing bases.
Current equals voltage divided by resistance. Like those little tiny raisins?
I mean, look at
currents?
the Mars, all the prime.
I love currents.
That's changing.
Me too.
Slowly but surely it's changing. But I have to be honest with you, when I was in Sweden trying to build a wind tunnel, and I had to get a fan, and believe it or not, Swedish manufacturers making these fans all spec'd out in American-style units.
So they're retarded.
They want to be like us.
We can design fans again, but.
No, I think just those kinds of things were better suited.
What they use like inches and feet,
Oh,
Pound
PSI,
foot.
PSI,
PSI.
horsepower,
horsepower.
yeah.
This is probably
Anyway, but that's a tangent.
What is that?
So, come on, Denson, are you serious?
Yeah.
A simple question like Coulomb's law. I would have to give you the formula.
What's Coulomb's law?
What is
How
a
about
rhombus?
this? How about this? I make it. You know, those of you who had exams with me know this. If
Her
you don't
exam's
know
tough, but she
something,
grades it fair. Very
if you don't know something, come and ask me. Okay? I'll take a survey of the class. If the class agrees, I'll put the answer on the board.
What's
No, I'm just joking about the survey of the class. No.
This is democracy.
dictatorship.
It is. I love it.
Oh, dictator passivity.
Dictator patrimony. So if there's something you don't know, then you come to me, and if it's a fair question, and I think it's something that, yeah, you should. Okay. Bottom line, I'll put it on the board for everybody to see. Okay. So if I give you a Coulomb's law question, you really don't know Coulomb's law.
You just put
Then-
Ohm's law. That'd be easy.
Yeah, let's do that one.
Yeah,
No
You're just trying to
brainer.
get inside my brain. It's not going to happen.
that'd be sweet. Ohm's law, though. Yeah.
So I would expect you to be able to flowchart the pseudocode. Pseudocode's easy. It's just English. Come on, you guys know that.
What's pseudocodes?
You know what I want?
Yeah, exactly. As long as it makes sense to me. It makes sense to the lay reader, the person just picking up your code from, not necessarily outer space, but not in your field, not a coder, and understand what you're doing.
Coulomb's law, and they'd be confused as hell.
Yeah, you don't want to use Coulomb's law. Math is okay in pseudocode.
No.
Simple like
Zombie
we're
you?
used to write. So F is equal to K times Q1
Times
times
Q2
Q2
by virus squared.
divided by the distance squared.
What is that for?
That's just the scalar Coulomb's law. I might throw a vector in there.
Would you give us the value of K? Like K
That's
equals
more,
some big number, 9.8 something, times 10, 19 or something.
Is there going to release on it or 7 equals 6?
You need to declare a double long.
Divided by 36 pi. Okay.
what is it? I can't read that.
10 to the 9th of
It's all
35.
it's
All right. So flow charts, and that should say and pseudocodes.
Is that
So-
okay?
So we looked at selection statements. Basically,
Commercial.
if else if, and then the switch. Switch this statement, true, do it, not, go to the next switch statement, and so forth, right? No questions so far? Okay, we're already up to lecture 8 then. Iteration statements, do all, for. As long as this is true, do it. Once it's true, stop. Nested loops, so like when we looked at filling that double array, nested loop. Jump statements. We didn't really look at the go-to statement, because that was an advanced C topic, but we did look at break and continue. I know a lot of you were keen on the go-to statement, but since it really wasn't part of this curriculum, it won't be tested.
When you asked us to deal with sin x over x being undefined, could we use break and continue in that condition where
You
once
could.
you reach that, do the break, take care of it over here, and then continue after that?
But you can also do an if statement in your loop, right? If it's this case, then don't execute this, set it equal to 1 or whatever the amplitude is of your sign. All right. So functions, remember the functions. So first we function definition, then our prototype, and then how to create our own header files, how to call header files from the basic header files in our C compiler library, and generic functions. So once we call that header file, then we can use those generic functions. And then obviously the plotting isn't going to be on the exam, since that's a CH thing. I just wanted to show you guys that because I think it's pretty cool that there is a development environment out there that has these plotting codes in there. And then recursive functions. We actually didn't really look at recursive functions, but basically when you're calling a recursion function, then you're just asking it to do something over and over again recursively, right? So
Newton's method.
What's that?
Newton's method for finding the square root.
Yeah, exactly. You would use recursion for that, and it's essentially, going out, making a guess, moving a little, making a guess, moving a little, until you get to where you want to be. So, arrays. how to declare an array, how they're stored in memory, how to initialize an array, how to pass an array to a function, either fixed or variable, and then have you make an array of variable length, and then also the various mathematical operations we can do once we've introduced arrays, so vector math. Preprocessing directives. So we, with well, you guys tell me what's the use of these preprocessing directive things? Did we just start using them in lecture 7?
It's kind of like a way outside of the main function to set up things, whether you want to do a constant of some kind or hey, go check out this header file. Just basically something that's not even in the main body. It steers some things around or includes something.
So it's an instruction set for the compiler to tell it how to compile all the code. And I can do it something as simple as what we did the very first day of class, which is call a header file to do I/O. All the way to something extremely complex, to say compile these levels, these lines of code if this condition, and these lines of code if that condition. Or checking to see what header files have already been declared. So it's very simple to the very complex, the preprocessing directive. So I can include a variety of source files, either in general or based on conditions. I can include other files in my code, and I can do conditional compilation. So if this is true, then compile this code normally. If it's not true, then go out and get this and compile this instead. It's pretty, there's a lot of power there. Predefined macros, so those go in with the header files, and then you can just go and use those in your code. And then the pragma declaration, which is, because it's very compiler dependent, that's more of a just that you know it's there, and I will probably not be on the test. So I don't spend a lot of time, don't spend any time studying that pragma thing, just know it's out there in various environments to use if you need to. You can check things like the status of the file, add files. Okay, and then I think this is basically the last lecture that will be included on the test, and that is storage classes and program structure. So remember that the different variables had different storage classes, and we had that little diagram. So you have just the program, file, and then the code. So those are the difference between global and local variables. And so each variable is going to have a scope. Is it within just the little block of code that we set aside with our little brackets, or is it the whole program, or is it the whole, or just the file, etc. So scopes of variables are identified, and then how those are stored in memory. So then you can have the static variables, so that once you go into your function and define it, it doesn't change. When I leave my function, I come back into my function and it stays wherever it was. So if it's an incrementer, and I'm going to call that function numerous times. So that's a static variable inside a function, or a static variable outside a function. It depends on how you call them. And then external variables and functions, so those are actually outside your program that you can use, and how to run programs with the multiplication of files. So that's it. That's basically all we've covered. So any questions?
Did you ever put lecture 12 on Blackboard?
I don't think it's just chapter 11.
No, but I will. That's the one we just looked at. I thought I did.
I was just
I'll
wondering
do
if
it.
something was wrong and I wasn't showing up on mine.